Hi guys, I'm Aaron Rumpf, and today what we're going to be doing is going over type 2 two-line can cycles for cutting the OD of my part. Okay, we'll be doing the roughing and finishing can cycle. We're going to be running a Fanuc code on a Siemens control machine. Okay, so it sounds kind of complicated. It really isn't, and I'm going to show you why. So here's the part that I'm going to be running. We're going to be doing this outside contour right here, so we're going to be starting here. And then we're going to slowly move our way through the part. And we're also going to stop about right here off the part, and then we're going to come up even further off the part. Now, it kind of seems a little bit redundant to have two moves going the same direction, but I'm going to explain to you why that's important. Okay, so we're not going to go through programming the whole part. I just want to show you how to format your G71 codes so that it works on your Siemens control machines. Okay, so with that said, let's go ahead and get our clear point. Okay, this is our clearance point, and that is where we're going to move before we execute the can cycle. So let's look at our part, and we'll actually kind of get an idea, or our code, and we'll get an idea of what we're looking at. Okay, so here's our code, and if you'll notice at the very top it says workpiece and it has a bunch of information in the cylinder. Now that is a Siemens code. Okay, so if you'll notice, it is a lot different. It actually has a word instead of G code, so that's how they're formatted. Okay, however, to put this into Fanuc, all we're going to do is simply type in G291. By typing in G291, that takes my Siemens control and puts it into Fanuc mode. Okay, very cool. One little code does all the work. Okay, a couple things I want to point out is I have a T0101. Most Fanuc controllers, you just type in T101 and it works. However, the Fanuc code on a Siemens machine wants you to put the additional 0 on there. Just one of the logics on behind the machines. Okay. Then I have a spindle cap. Normally that's a G50. On this machine, it's going to be a G92. And you'll run into that a lot whenever you go from different machines. Different codes will work differently. That's why it's good to have a good understanding of what machine you're on. Okay, so enough with that. So let's come up to here, and all this is what's going to go, all this in parentheses is what's going to be inside my G71 can cycles. Okay, so again, GO, G54, this is my clearance move. Okay, that's that clearance move right here that's up above my part. So if we look there, we'll see that it's a 2-inch material. I moved up 100 thousandths off of the part. Okay, now I also moved 200 thousandths in front of the part in Z. Okay, so if I have to take off 100 thousandths of material off my first side, I can just simply move my whole offset in, and without colliding with the face of my tool, I still have that 100 thousandths of clearance. Okay, that'll make a little bit more sense as you're programming your part. Don't worry about it too much right now. Okay. So from my clearance point, we'll go back to my program, and we'll see that we're going to execute our G71. Now, the first G71 line only has 2 variables on it. I have a U, which is depth of cut, and the maximum depth of cut that we're going to be taking today is 50 thousandths. And then I have an R. Okay, now R is the retract amount. That's just the amount to get my tool off of the part so that it can move away from the part. Okay, because you don't want it to drag across the surface you just cut, or else it'll mar it up and make it not look really good. Okay, so 10 thousandths is all I need. You can put 100 thousandths in there. It's whatever you want to put in there. Okay, so the next line of code will actually look very similar to a normal type 1 G71 can cycle. Okay, I have my P10, my Q20. Okay, the P equals the N, so that's where my can cycle starts. Okay, at X0. And then my Q is where it ends. So down here, when I'm moving off the part. Okay, so that means all that is going to be in there. This is all my turning right here. Okay, so another thing I want to point out to you is the U is going to be the finished allowance in X. Okay, so what does that mean? Okay, that means how much material is going to be left on the part before my finished can cycle runs. So let's kind of give you a look at this real quick. So if I'm looking at this dimension right here, okay, 1 inch, 450 thousandths. After the G71 code has ran, it will leave this diameter right here at 1 inch, 460 thousandths. So after the G71 runs, that's what that diameter would measure if we did not run a G70. Once you run the G70, it will put the material at that dimension, okay? So that's all it's doing, is just taking off that excess material that the G71 left on there. All right, so let's go ahead and erase this. And we'll come back to our program real quick. And what we're gonna look at now is just the very end of it, okay? So I've got the U, which is my excess allowance in X. My W is how much I would leave on my Z surfaces. So the shoulder, I just leave 5 thousandths. Then I got my feed rate. Now my feed rate for roughing needs to be between 12 thousandths inches per revolution and 15, okay? That's a good way to get your chip to be breaking off, and it's gonna give yourself a good finish, all right? So remember how I told you we're gonna move up, make sure I got the selecting right, okay? So if you notice, my material's 2 inches. I moved to 2 inches, and then normally on the N20, I would be turning off cutter comp. On this part, I'm not using it, but that's where I would put it on there. I would turn it on N10, and I would turn it off on N20, okay? However, if I was to turn it off while moving away from the part, it would make a diagonal move, okay? So that's why we want to come off the part and then come off the part again, all right? So now, I've got my part ran. You'll also notice X 2.1. Now, if you'll notice as well, my clear point was also X 2.1. Very critical that they are, I usually keep them the same, but it's critical that this value of 2 inches 100 thousandths is not more than the clearance point value right there, okay? The reason why is the machine's logic says, okay, there's not any material, I moved past the range where I can cut, okay? So I usually keep them the same, but for example, if that was X 2 inches 101 thousandths, that's 1 thousandths greater than that, and the machine will alarm out. It can be lower by any amount, but it cannot be greater, okay? Something to remember. So I always make them the same, okay? So with that said, once it roughs this part, all it's gonna do is go into G70, P10, Q20. It's just gonna run a finishing can cycle, okay? So one thing to think about, if you noticed, I have a feed rate of 6 thousandths. Well, I also have a feed rate of 12 thousandths. So wouldn't the feed rate of 6 override the 12? In this scenario, it does not, because the machine's logic will only run this feed rate while executing a G71. And if you put your feed rate, if you put that 6 thousandths right here, the machine will not read it, okay? The machine will default to a feed rate of 12 thousandths per revolution, and it will not work. That's why you must have it on that line when you're coming to the part, okay? So with that said, I've gone through and I have successfully done a G71 2-line can cycle, and then I have also finished with that right there. So with that said, that's how you would do a 2-line type 2 can cycle for OD work. So if you have any more questions, just give me a shout or come see me. Again, my name is Aaron Runk. Thank you for watching.